So participants will
Yes.
join. Yeah, we'll start. Good evening, everybody. We welcome you to the day 5 of ATAL-FDP-AETSEC at IIIT Kottayam. So today's talk 1 will be given by Dr. Kashi Vishwanath Ponnapalli. Dr. Kashi is an esteemed professional in the field of geospatial technology, boasting a comprehensive 24 years of international experience encompassing domains such as photogrammetry, LIDAR, 3D laser scanning, geographic information system, GIS, and remote sensing. Dr. Kasi holds a double master's degree in earth sciences and has acquired certifications by participating in online GIS courses offered by University of California and has earned a PhD on the topic Water Vulnerability Assessment of Visakhapatnam, Andhra Pradesh. Dr. Kasi commenced his professional journey at BLOM UAE in Abu Dhabi as a photogrammist and progressively ascended the career ladder to attain the position of subject matter expert in geospatial science. To disseminate his expertise globally, he has established GeoVidya, an online learning platform dedicated to geospatial education. Through this initiative, he has successfully transformed over 3,000 graduates into industry-ready geospatial professionals. We welcome you, sir, for the talk.
Thank you very much. Good evening to all. Thank you, Della, for your nice words and introduction about me. I'm privileged to be here with the August gathering of doctors, faculties, super scientists, and all. So, good evening, all. I'm looking at the chat box. Say good evening if you are ready to experience the talk with me.
Good evening.
So first of all, I request all of you. Yes, Adela. Yeah, first of all, I request all of you to bear with my Andhra style talking. My English is a bit different, not like Anglicized English like Dalla speaking. So most of you people are very good at English, but I'm not that familiar. So please bear with my English and try to focus on the content which I'm going to share and try to interact with me so that together we can learn, gather knowledge through this ATAL sponsored AICTE learning endeavors. All are ready? Say yes.
Yes, sir.
I'll share my screen. I like that energy. So meanwhile, if you find anything difficulty, please bear with me. So are you able to see my screen?
Yes, sir. Yes, sir. Screen
are
is
you
visible.
able to? Okay. So what is the topic of the day? It is AI in geospatial technology for climate modeling and extreme weather predictions in the next wave of smart utility. Actually, all these days I am looking from the surface to the, from the air to the surface because I'm a photogrammetrist and geospatial technology related professional, where I work on the data with aerial photographs and satellite images, which we look from the top to bottom. But this particular context, climate modeling and all, is forcing me to look from the ground towards the sky. So what is happening in the sky, especially stratosphere and stratopause. So those areas we are going to explore how we can predict or model or do some kind of study on it. So agenda for the day, we'll try to do some kind of introduction to geospatial technology and AI, importance of climate modeling and extreme weather predictions, role of AI in geospatial applications, case studies and real-world implementation. Some of the case studies I'll try to showcase, and challenges and opportunities and the future trends in smart utility systems. Finally, your favorite area, questions and answers. All right. So to understand the natural intelligence, so the natural intelligence means which we have procured from our evolution, right? From the age of the earth, we have evolved into this kind of setup where we have eye, nose, ear, tongue, everything for sensor organs. So any remote sensing method employ these sensor method technologies only. It's only a mimic the natural intelligence for the purpose of artificial intelligence. So to conquer natural intelligence with AI is nearly not possible. So here we can see I is related to optical band of electromagnetic spectrum, and our skin perceive the visible light and the infrared band of the electromagnetic spectrum. Our ear is, all that's radio frequency, radio waves and all. So these are the some of the frequencies. Means if I say frequency means we need to have a look at the electromagnetic spectrum, which is the entire energy which we are receiving from the sun. 1 second. From the sun has been categorized into bands. Those bands, how they interact with the real ground scenarios, and they created. So if you study the bands, the one which we are able to see is visual band, that is from 0.4 to 0.3, 0.4 to 0.7 microns. And with our human intelligence, we create sensors to measure the bands of, So that natural intelligence created us to perceive these part of these bands, frequencies with our ear and eye and skin. So with that, we identify the environments and we'll take the decision using our CPU or mind. And sensor technology, we as a human being created to sense optical bands, infrared sensors, radio sensors, and sonar sensors. Using these sensors, we get the information from the real ground environment, and we use those signatures to process further for the analysis. So using all these sensors, we go to geospatial technology. So the components of geospatial technology are mainly GIS and GPS. So geographic information system, global position system, these two are pivotal for 2D and 3D mapping with the geodatabases. And my favorite area, photogrammetry, for the planimetric and topographic data collection, where we collect, where we use stereo pairs from the aerial platforms and the satellite platforms, so that the perspective positions, different perspective positions, which will enable us to see the world in 3D. 3D means the X and Y and especially the Z component, which are mainly vital for the DTM, DEM, slope kind of analysis. And the surveying is the good old technology where we measure the points of the points on the X, Y, Z coordinates, and which is still a prominent, powerful method. We use these points to rectify the errors in our remote sensing and photogrammetry data at the time of aerial triangulation and all. We use these points and the fixed GCPS ground stations, and we use for the corrections and all, and for the enhancing the quality of the data. So with these components, so far we are using small scale data and small scale kind of applications. The latest advancements in LiDAR and 3D laser scanning, where we use infrared and near infrared band of electromagnetic spectrum, and we use mainly LiDAR to get the distances from the sensor to the object location, just distances. That can be, if you place a sensor on aircraft, it will get the height from the ground in different locations, so that ultimately we'll get the ground elevations above MSL. That MSL, that elevations will come under as a form of DTM, DSM. So with further analysis for the slope related analysis for water movement, erosion patterns, environmental hazards, this kind of thing. So for that purpose, that LiDAR data. So even recently, the LiDAR instruments are being mounted on the cars so that they will get the roads and moving objects identification for the mobile laser scanning analysis, MLS analysis, for the autonomous driving, this kind of technologies. So this is also part of laser scanning, where we collect data from the close range objects for the high accurate data up to millimeter accuracy. So using all this data, getting all the sensors, getting all the instruments and all, what we do kind of study on the earth. So what is there on the earth? Presently on the earth we have 8.2 billion people. 8.2 billion people means on an average one person weigh 50 kg. 8.2 into 50, that much of flesh is on the earth's surface. That flesh is under the influence of environmental temperature, let's say radiation from the sun, and the surrounding climatic conditions. It's under influence. So with that influence, the flesh is there. Besides our flesh, what else is with us? Along with us, these are also part of our environmental ecosystem: birds, plants, and animals. So all these are on the earth surface under the influence of natural calamities like the earthquakes, floods, and other natural hazards. Plus, we ourselves are making the environment very, I mean to say, unfriendly. We are creating an unfriendly area, which is making more danger. So, can we bear or can we keep it healthy from our waste endeavors and the pollution from the cars and spillages, so many other environmental unfriendly activities which we commit. So for that, so do we have any system or method so that we can monitor, measure, and make it more friendly? Is there any other system? The system is geographic information system. So this is the main, technological advancement, I should say, for the living people on the earth. Using this system, their mobility, their living, their happiness, their comfort, everything is being monitored, measured, and programmed, and predicted. So many things is being happening, which we are going to discuss further in the slides. Okay, so to get all these things accurately, what we did, we created a earth into a model. That model will give us a precise location. That precise location will give us what is there in that location, how it is there, how far it is from other locations. These kind of things, you are all familiar with the coordinate system. Just for the sake of understanding, in my way, I'll just try to explain it here. So here, the radius of the earth is 6378 kilometers. The perimeter of the earth, if we calculate with 2 pi r, this will be it will be 40,000 kilometers. This is the perimeter of the earth. Is everybody able to? Oh, sorry. So for 40,000 kilometers, in 24 hours, if it is rotating on its own, meaning 1 hour, it is moving, the part which we are standing on the earth will move 1,666 kilometers. In 1 minute, it is 27.8 kilometers, which means if we are sitting on our chair, after 1 minute, we are away from the chair by 27.8 kilometers on the earth's surface. That is the fastness of revolution of the earth. Besides this, if you see the 360-degree perception from the Earth center, with 360 degrees means 40,000, 6 degrees means 666 kilometers, and 1 degree means 111 kilometers. I'm just telling this one to understand the UTM coordinate system. Because the UTM coordinate system or any other measuring systems are used for the assessment of the quantity, area of the geospatial phenomena or yeah, the species, I would say categories like land use, land cover area, water area, like surface area calculation and all. So this is the basic input for any calculations which we do on the Earth surface. I know you know all these things. Just for the sake of my momentum, I just inserted this video, which I created while I'm doing for my students. So finally, we have our
So your voice is not audible.
okay. Oh, my video is paused. Okay, now I can do it here. So are you able to connect with this? Let's say the explanation. So finally, we have latitudes, longitudes, and north to south. That longitudes are separated by 6 degrees, and east to west by 8 degrees. Ultimately, we have our UTM coordinate system. Here we make a zones of entire Earth. Because I put this one here, I'm going to talk these cubes later in the slides where you will appreciate more. So each cube, here this is I'm going to say 8 by 6 degree cubes, I'm going to say squares, and there we are going to discuss about the 2.5 square kilometer cubes. So what those cubes we will learn at the time. So next comes AI and geospatial technology. So here, AI and geospatial technology together provide an enhanced like lens to view and solve the global challenges. Their integration not only to transform traditional workflows, but also opens doors to innovative applications, particularly in addressing climatic change, sustainable development, and social needs. For example, this urban planning and disaster management, agricultural crop management, and environmental environment. All these are for the benefit of human being by the human beings only, not by anything. Because we are only understand the nature, we try to understand the nature and we try to keep the nature in its own intact position so that we will live happily. For that sustainability, towards the sustainability, we will plan, execute, and process with the activities on the Earth surface. And climate monitoring and many more of them. So what are the advantages of AI in geospatial technology? Because earlier we have seen 8.2 billion people on the Earth surface. Each has got name, their weight, their address, their place, and if they have any other, I mean, say like, their diseases, their health, their emotion, everything. All the data is being recorded in one data. So to have the data and process the data in real time, it is not possible by human beings. So that is the reason why we take the assistance of AI, meaning the with AI we can process and analyze not only the satellite data in real time, offering insight that were previously impossible to or took so much time earlier it is to take. But now using AI, we are processing in minutes depending on our processing system. And using this one, we cannot predict earlier by the ordinary hard copy maps what will happen in the future. We only, with our intuition, we try to, like a scientific people, so I would say very senior people are able to guess what will happen by the Darwin principle. Present is the key to the past. Whatever is happening in the past. So from the present happening, they will predict in the past. But with AI, with the data, we will predict future by what is happening now. So that prediction by training AI on historical data, we can forecast and predict changes to our environment. Imagine prediction one prediction of flood weeks in advance or forecasting urban growth, this urban agglomeration, everything. And then and since we are not involved in big data, I would say huge data, AI will enhance the accuracy, precision, and can spot subtle changes or patterns that may have overlooked by the human beings. And democracy, and we can share the analysis globally by the policies and all, I would say, provided by the institutions and the data providers and data owners. So AI will help us, but AI with the AI, we can process huge data in less time to save time for the benefit of the future dangers to identify. So extreme events means so this year we have enough rainfall, but for the past 4 years there is not enough rainfall. The reason being somebody telling El Nino, La Nino, they are telling. So what is El Nino, La Nino? So these are the phases of southern oscillation cycle, a natural climatic pattern in the tropical Pacific Ocean, and that is El Nino. And the western phase of the warm phase of the ENSO cycle, characterized by the above average sea surface temperatures in the eastern central equatorial Pacific. El Nino occurs when trade winds are weaker than normal, pushing warm water back east. So the cool phase of ENSO cycle is characterized by La Nino, and the warm water is by El Nino. So why this Pacific huge water body is getting warmer and cooler? Because of the earth is rotating on its own and it's revolving around the sun, and we have our moon with which our earth is getting inclined by 11 degrees, and when it is rotating that Apache and Parachi, so it is getting that inclination for every 3 to 4 years. The sun radiation affects the Pacific water warmer or the cooler because of the we have Tropic of Capricorn, Tropic of Cancer movement, up and down movements. So because of that, the warmer creates and disturbs our monsoon system in India and creating the La Nina, El Nino effect with which our climate is getting affected. This also became one component in the analysis of our AI models for the climatic disasters. So here types of extremes can be hurricanes, droughts, floods, and wildfires. And we mainly these are because of the temperature change, atmospheric pressure, and ocean weather, ocean temperature and cooling patterns. So here mainly the geospatial technology role in identification of the surfaces by mapping it, naming it, and quantifying it, so that we can forecast what will happen in the next map, how much change it has happened. So it will be enable us for the risk analysis. So for example, so I have worked on the crop monitoring system. This is a agricultural system mainly. So for this, we download the data from the 30 centimeter data we all download, from the USGS website, and from there we create them. And using the Survey of India, our well-known Survey of India, classical Survey of India maps, we geo-referencing them, and we create vectors for land use, mass, soil, and slope, elevation, and all. And those data will ultimately create a kind of crop culture. So for the rain-fed crops and river-fed crops and groundwater-fed crops, so these kind of crops are different in nature in their requirement of the water and the temperature conditions. So those kind of crops will collect together and make it a group. And next, we use the raster data from the Sentinel platforms. So that from there we use supervised classification or unsupervised classification, and we'll create again some kind of clusters, same kind of classified crops. And using this data, we name them. What is the crop type? How it is there? Is it healthy or something? We'll create that one. That will also come under the one more layer. So the previous layer on the top of the previous layer and this layer we overlay, and we use our mode is satellite, which directly it will give that normalized difference vegetation indices and normalized difference water indices. So these kind of data we will overlap on it, and we will further strengthen the accuracy of that model, and will give the crop conditions, current fallow land, this kind of, because ultimately we want to make the farmers more engaged, more informed for the purpose of the which kind of crop they should put in the event of disaster. Maybe less rain. Next year we are going to get less rain, so change the crop pattern and all. So we are predicting the next year weather conditions, and we'll suggest them crops by seeing the conditions from this remote sensing and I would say geospatial technology data. And we use this huge data by using AI models, and ultimately we will give them. So some of the companies, organizations are already working on it. So if they give the position of their field, and it will give, you are suggested to put these kind of crops in your area because the conditions are like this, it will be at their fingertips. So those kind of applications are being developed. So of course, this model is very old one, but I just try to analyze this one. So finally, the farmers will have an app in their phones, and they have informed, and they are well informed while having the present crop also, which crop they can grow for next year. So that one. And this is my special area, where I did my research in Visakhapatnam, where is Willily undulations and fast growing urban agglomeration. And I want to study, do they have water for drinking in the near future? Will there be any problem for them for the drinking water or the potable water in the future? So for that, I did my PhD on it. And using this one, what I did, I collected the Landsat data bands, and I did the supervised classification, and created the SRTM, and ultimately I created the layers for groundwater recharge, geomorphology, slope, groundwater levels pre-monsoon and groundwater levels post-monsoon, land use cover, evapotranspiration, impervious surfaces, population density, lineament density, stream order. So these are the factors I consider that will influence the availability of the water in that particular area. Any area, these factors will influence, but my study area is Visakhapatnam. So there I use all these factors, and I created one factor to other factor, how it is getting the and mileage. I would say one factor is slope is there. If it is steep slope, it will not allow percolation. Runoff will be more. And if it's a flat area, there is penetration and percolation will be more, and it enables recharge for the groundwater. Like that, I consider all the factors and I put all the factors in the hierarchy of this what we call SATI has suggested this model. And he who used to use for 1 to 9 categories, but I use 1 to 5 categories. One is very friendly, 5 is not friendly. Like that, I characterized all the 11 factors and I compared one factor to the other factor and I normalized this pairwise. And finally, consistency index also I calculated with consistency ratio. And finally, we'll get the numbers for the pixels of that area. So that pixel will give us different 1 to 5 numbers. So 1 I know which is very friendly for the water availability. And 5 is not, I would say, water is not available, it's not friendly for the water percolation system in a hydrological cycle. So like that, we created a model, a map for the whole entire Visakhapatnam district, and I calculated that areas which are under high stress area, medium stress area, low stress, and there is no stress because usually in the northern my study area there is a river is there, flat sand area, and the people also living there. Those people are not encounter any kind of water stress. So that kind of study also I have done it. And here the data which is supervised classification, unsupervised classification using Google Earth Engine, where I use some of the modules, AI related modules for the purpose of getting my results. And next will be the geospatial model recently. So AI coupled with AHP and MCDM, whatever my PhD area. So there mainly the risk assessment and zoning. So AI-driven geospatial analysis identifies the risk zones while AHP and MCDM prioritize the mitigation strategies based on the diverse criteria. Meaning, so geospatial technology means we have vectors and rasters and names. But this AHP and MCDM doesn't know those vectors or rasters anything. It will only know the number. So that number we conclude from the analysis of the area. For example, land use land is there, land use land cover is there, soil, so vegetation and concrete surfaces. So these kind of areas, we know the area and we convert it into raster. In the raster, we have the digital numbers. That numbers from that numbers we say reclassify them into 1, 2, 3, 4, 5. Because in digital numbers we have 0 to 255. For water, we have certain segment of the numbers. For greenery, for the soils, different segment of numbers. So that segment of numbers, we have to assign weightages 1 to 5. So that weightages only that AHP model will read it. And using that, it will infer the solutions. Because, so this one, analyzing the data, giving this one, it will be very, very quick in a real-time environment because in the website, recently the cloud platforms, everything because of the 5G enabled devices and all they are giving. So we'll experience that one while the final slides of my session, we can see them. So dynamic decision making. Real-time geospatial data enhance the dynamic applications of AHP and MCDA models during disaster responses because disaster response using geospatial technology and AI will not give that accuracy. So if you add MCDM weightages for some models, predefined models, and if you use them, it will give, or at least it will enhance the accuracy of our models. And the AI models also simulate disaster scenarios like, this will feed the framework of robust contingency planning. So in the sense, it will predict to AI models simulate disaster scenarios, feeding MCDM frameworks for robust contingency planning. So meaning is for the planning purpose. So because people will ask in Hyderabad, recently it is happening, Hydra. So where there is a lakes and the urban agglomeration and the government is, I mean to say, scaffold, I mean to say, demolishing some of the buildings. And if the buildings are demolished, and the owner will claim about the against the government, why you demolish my buildings? To confirm your building is, I mean to say, affecting the natural environment. So that is the reason we are taking, as being a government organ, we are taking action against building to, I mean to say, supplement data. Using MCDM, they can do, because the simple methodology we use for the change detection. Lake in 100 years back, every 5 years, how it is changing, and the agglomeration, how it is changing. We will lay over the water data to the construction data, and we can create a kind of buffer, and we cut that polygon, and this is the areas we are going to that comes under the FTL buffer, or this water area buffer. And if we say that one, they will not, I mean, say, agree for some times. But for the analysis of the second opinion, second calculation, we use the MCDA method. This is how, because we are not using just geospatial technology, only one layer or two layer. We use multiple layers and using that criteria. So meaning, so because of this lake reduction, and the whole Hyderabad will get affected, and not because the environment will change, everything will change, the future generation will affect, and this is the problem. That's the reason why we are taking this action, just to supplement it. That kind of actions will be taken, and at the same resource optimization. The integration helps allows resources effectively considering spatial and multi-criteria factors like population density and infrastructure resilience. So that how the MCDM integration with geospatial AI will give better results than just normal geospatial AI. And not recently, as a part of my career in IAC Technologies, I associated with Integrated Coastal Zone Management, where I trained Survey of India officers and all for the purpose of tsunami mitigation plan, the ICZM project. So there we use the aircraft data, like I would say flights, they will fly above the coast, 11,000 kilometer coast of India, and they collected the data. And the data is, so 90 degrees to the coastline, 7 kilometers towards the land, 1 kilometer or 1.5 kilometers towards the sea, and that stretch, the band of the coast, Indian coast, they have mapped with all the vector layers and the DTM layers, so that the MSL, above MSL, wherever the slope gradient is flat, it will go towards the, I would say, if any tsunami comes, it will go towards the land. How much area it will inundate at the time of tsunami. So for that purpose, they have created the hazard line, considering the past 100 years sea coastline, and wherever there is a high tide area or any other cyclone, at the time how much area is getting affected. Like that, they have created one line on the earth surface, 90 degrees from the coastline. So this much area they have considered to be monitored and not to allow any constructions and all, because at the time of mitigation, it will be very difficult for the government to move the people and all from there. For that purpose, they are making some kind of regulations in that zone. So to identify that zone, so this ICZM project has been executed by Government of India. And this is the area where I'm talking about integrating Earth system spatio-temporal data for impact assessment of climatic extremes. So this is very, very interesting, So deep extreme cubes is recently introduced databases. So where 2.5 square kilometer area from the ground to the stratosphere, like columns. So that columns will have satellite, will have I would say, analyzed data from the satellite image, climatic variables, land cover data, topographic data. So using all these things, so how that cube will affect for the, the climatic endeavors. So that cube. So that is prepared like a, when we go to If you feel like to eat curry, we'll go to some curry point and give me some curry, maybe chicken curry or fish curry or any vegetable curry. We'll take the packet and we eat it. Meaning it's already prepared by someone, ready-made to eat for us. In the same way, these cubes are like the packages which we can consume in machine learning algorithms directly. So that's a recent. I'm sorry, I read this on one paper. That's the reason why I included here. So that model will make more quickly than the entire cycle of that processing. So like that, I like this one. Okay, so which means by using this model, we can identify areas vulnerable to specific climatic extremes, developing early warning systems for extreme weather events, and assessing the long-term ecological impact of climate changes. So these are, I would say, if you execute our regular AIML procedures, it's already ready-made samples which the AM can consume. So I liked it. Then some of the AI, open source AI-driven weather forecast models. So there is a graph cache. This is from the Google DeepMind. Based on the graph neural network, GraphCast provides high resolution global weather forecast up to 10 days in advance. It is trained on a decade of historical weather data and outperforms traditional models like ECMWF, high resolution forecast system in speed and accuracy. So it will deliver predictions in less than a minute about prediction. See how beautiful it is. Supports early extreme weather warnings and cover atmospheric variables of multiple attributes. Recently, I heard that earthquake monitoring system in Japan. So whenever there is earthquake is going to happen, 1 minute before, all the mobiles to that area will get the message alert very quick before 1 minute, so that they will take preventive action going to safe area something. In the same way, here in 1 minute, this GraphCast will enable the decision. And whether this global forecast technology, whether global forecast system, this also a hybrid of physics AI model combining partial differences between partial differential equations with neural networks, weather GFT excels in producing fine-grained temporal scale forecasts up to 30-minute intervals based on the hourly data. And the state-of-the-art accuracy for nowcasting and medium range predictions with adaptive AI corrections and bias reduction. And this AI forecasting system, this is also a beautiful system developed by ECMWF AIFS, focus on 6-hour to multi-day forecast using deep learning and auto regressive strategies. It incorporates historical data such as ERA5 and operational analysis data for training. So employs rollout techniques for long-range predictions and optimization strategies for atmospheric state modeling. So whatever we see from this table, without the previous data, AI cannot do anything. So without previously processed, analyzed data, AI cannot consume for its operations to give the solutions. Okay, so that's what I understood. And any, I would say, application if you want to create for the cyclone tracking. So initially we need to have a data acquisition, like, gather cyclone data from the sources like National Oceanographic and Atmospheric Administration, NOAA, or relevant agencies. And we need to add the satellite imagery for the real-time tracking, data processing and visualization. Utilize GIS for data analysis and visualization of the cyclone tracks or map. And app development, choose a mobile app development platform, iOS or Android or any other cross platforms. And design user interface for deploying cyclone tracks, intensity and potential impact zones. And deployment and maintenance. Usually, once we deploy, So because this app will consume the data through cloud or any big data principal buckets, and it will retrieve the data. Since 5G is in operation, the bandwidth is available for us. So it will consume the data and has established procedures and using AI or ML and all. So it will create the output and it will showcase to us. During this entire process, if there is any glitches, then we have to, work on it. Like, Google Play, Apple App Store. So we can, for the distribution of our app, we can use this one. And then continuously update the app with a new data feature, because Earth is dynamic. It will change every time. And we need to change the input data time to time for our customers happy. So shall we try to see some sample weather app? Say yes. Shall we try to see a sample app? I think yes. Okay. So this I like because I'm using in my phone. So I just want to show to you. This app will acquire the layers and source. So this app will get the feeds from the NASA, NOAA, ESA, and JAXA, and weather data from meteorological organization such as National Hurricane Center, Joint Typhoon Warning Center, Global Numerical Weather Models, and live wind and atmosphere data are surrounded from models like NOVA, GFS, and EMSF and ERA5. So these are the source data which this app consumes, and it will process the data like normal geoprocessing tool, remote sensing, because of projects are unsupervised. Supervised and unsupervised, same kind of methodology will also use using the dynamic AI system, and it will correct the images, radiometric correction and cloud masking and atmospheric correction for clarity, and images are stitched to create a seamless global mosaic. Because here, if we create a mosaic of very small scale, small size and high resolution to retrieve the data, it needs to retrieve huge data. But then it will clutter. I would say it will stop and start like happening. So for that smooth happening, it will create a global mosaic, and it will kind of retrieval 1, 4, 8, 12, like a kind of pixels. Initially it will load, then it will fill the other pixels as quickly because our eye is not able to perceive that processing. So step by step processing, it will use that kind of methodology to showcase the data. And weather model data, numerical weather predictions data is processing and generate visual representation of wind speeds, directions, cyclone tracks, and all. So these are already from the satellites process data, it will consume and it will display. So this app will not process any data. It will only front end application. It will showcase using the backend data from the cloud source or our esteemed organizations prepare data. It will connect to WebGS or web portal, web internet, this kind of thing. It will retrieve the data from there and it will show. And the gridded formats like GRIB, NetCDF are used for the wind, pressure, and other meteorological wind. Because so here not only one layer, there are multiple layers are there. Each layer has got a kind of parameters and characteristics. To retrieve the data from the cloud and to display, it will use this kind of gridded data formats and NetCDF kind of data to use. It will use. So meaning live wind and atmosphere data are sourced from the NOVA, GF, and ECMWB, DRA. And finally, visualization. So what we expect from the visualization, usually here they use web Mercator projection for rendering maps and all. So earlier I have shown the UTM projection system because every data on the earth without projections it is a waste. It is a garbage. So that should be pointed, named, and quantified. Then only that will be an information. So otherwise we cannot use them. We cannot take any decision on it. So here also we have Mercator projection system, which is the subset of our UTM coordinate system for the purpose of displaying, because relative sizes will be rendered to view perfectly by this system. Because in the laptop, if you see the same data, and if you phone, if you see the same data, there is a different perspective. Aspect ratio is different, everything is different. But to fit into that vision, so they use web Mercator position so that here different kind of data, either satellite data or cloud data, atmospheric data, or sometimes wind patterns also. Those kind of everything will overlay exactly on top of it. So at the same time, readable geometric corrections, everything. And here for the smooth display of that app, they use Leaflet.js or Mapbox, GLJS for lightweight and interactive geospatial visualization. This CCM JS also I like most because here the 3D rendering of the entire city we can render and showcase on the web portal because it's very smooth and very very lucid, very nice one. So the CCM. So some of the applications, the CCM.js also is implemented, used. And this WebGL is also a rendering I must say layer for the visualization of the wind because it uses Python libraries like not Python library, so JavaScript and libraries using D3.js and Windy.js. So when we see this one on the application, it will be very pleasing for our eyes. So particle-based animation simulation, wind direction and speed, because because of the pressure, temperature, the wind moves from one place to other. If any cyclone happens, and we can see the movement of the particles will make us visualize how the wind moving, how that circulation, how that and I would say the system, cyclone system is happening and moving laterally at the same time rotating on its own. This kind of visualization is Windy.js and what's the library will do for us, and data grids. So these data grids are interpolated and visualized as animated flow lines. Okay, that's what I said. So cyclone visualization. Real-time cyclones positions are overlaid as tracks, poles of uncertainty, and wind radii and color coding symbols indicate cyclone strengths. For example, cyclone at the time of starting, it will be green color. When it is going faster than the expected, yellow color. If it is in the danger levels, red color. And again, at the time of subsidence or land falling, so the colors will come to yellow, green, something like that. So those kind of coloring also they can give for the tracks for the purpose of visualization. So the in the final delivery layers will be services like Cloudflare or Amazon Web Services, CloudFront ensures that fast delivery of maps and satellite imagery globally, large-scale caching, and reduce latency for high traffic users. So if more people are using the same thing, they should not get affected. That's the reason why this kind of technology they have used in the API. So backend API fetch satellite imagery and weather data on demand, and third-party APIs like Windy, Nova, because these are the proprietary organizations where they are, I mean, say, very matured in creating the data. So that data, they are by subsidiary or some kind of arrangement, they will allow us to use or consume that data into the app. So enhance the data sourcing for a specific feature like wind fields or storm forecasts. One second. This web interface built with a responsive technologies like React.js, but HTML product, HTML systems, and Vue.js for seamless browsing across devices. Features interactive layers like zooming, panning, and exploring specific regions. And the pitch zoom we are using, no? And optimized for UI, mobile browsers, possibly progressive web apps for mobile like experience without downloading from the cloud, right, direct from cloud they will access, and they allow users to toggle satellite images, wind animations, cyclone tracks. Like our GIS application is there, we can switch on, switch off the layers. So if you want to see only satellite images, we'll switch off the vector layers, and language didn't cover. We can kind of segregate the layers. The same way, if you want to see only cyclone track, we can see, and wind directions we can see, temperatures we can see, dew points we can see. So like that, every layer has got a individual control so that we can display on off. And at the same time slider. This time slider for the past cyclones, whatever happening in the life and real time, that will be stored and to review for the further analysis for the research purpose and all, or to consume in the AI models also. And time and rainfall data. So combine satellite imagery and real-time cyclone tracking data, example JTWS or any NHC. So display the current position, forecast path and intensity, storm structures and overlays. Here, current position means I am with my mobile in Hyderabad. So it will switch to my locations, geolocations, and it will zoom to that area, that geographical area and the map and the app. So that kind of geosyncing is also part of the app. And interpolated grid data, wind speed, direction data, as we discussed in the two slides before. Data taken from the models like GPS and GFS and interpolated into fine grid and animated using particle systems. This we have discussed already. Yeah, real time AWS and Google Cloud and data synchronized schedule jobs ensuring satellite images and weather models and update in the near real time, almost real time. This app usually updates in 15 minutes. So whatever the data, and it will predict up to 15 minutes because I'm not subscribed to this app. This app is in my phone, so I did not subscribe this one. So in GIS, the beauty of GIS is if you select in the data table any say data, it will reflect on the graphic user, say on the map. And if you select on the map, the data will be selected interactively. So the data maybe CSV or Excel data which are stored in the cloud from the NOVA or the concerned organizations. So the data will be say retrieved from there and it will showcase to us. See here, web interface and mobile interface and overlay controls, cyclone footage, displays, and interpolated grid data and real-time operations and data synchronization. So these are the happenings. We'll try to play this video, try to watch it. Are you able to see the moving window? See here, I am selecting the data in the table and the image is moving. It is past data. It is a cyclone Osagi near Philippines happened on 14th November. Now it is landfall, green color. On November 16th, there is one more cyclone happened in the same place. And this has, I mean, say, this cyclone not only happened in only one day, no? Some days together. So you can see here, when I click that point, that is a graticule I'm talking about, cube. 16 November, 5:30 a.m. Every 3 hours, the data is getting classified and updated. Every 3 years. But display will be 15 minutes. This is Beki cyclone, happened in the same region. See here the pattern, color change. And when we see here, when we press here, the cyclone, that I, is also moving and adjusting in a real time by downloading the data from the server, and it is displaying here. And you can see the controls here. In the bottom left side, there is layers, and right side we have different. So I think you might know this one. What is the recent cyclone happened in our Chennai area? This I recorded day before yesterday night. See here, the weather app layers, satellite data, radar data, precipitation, wind, temperature, humidity, and dew point, pressure and all. So these are all the layers. We can see all layers. We can deactivate some of the layers because we have bottom left side, we have a layer control. There we can switch off, switch on. What are the layer if you feel like to, or if you wish to, or if you want to close observation, that layer you can on and see. Just above the play arrow, no, there is a above. That is the layer panel. So I had just pinch zoom. I did not promote this one, but it's a beautiful app I have seen for the real time, I mean, say visualization and to plan our journey. If you want to plan to go to Delhi or any other place, if this app will give us what is happening in that particular area, what is the climate there, is there any hazard thing is going to happen. So those kind of data it will give for us in our hands itself. So by having this information, prior information, I cannot say 100% it will happen. Only confidence is 87% something on this app. So meaning, so because day for yesterday, they planned and they announced in the newspapers and radios and TV, there will be 3 days rains are projected in the Chennai and some parts of Andhra Pradesh. But there is no rain in Andhra Pradesh because now it's winter is happening, land is cold, and the air is heavy, and it is not allowed to come onto the land surface. It's not warmer condition. So that's the reason why it is deflected towards the Bay of Bengal and passed through the, I would say, towards the Bangladesh. It's not even cross the land. That purple color is the track of that cyclone. And sorry. See the beauty of this app. So wherever there is a color, also they have given for the humidity percentage and water content percent in the clouds. Depending on the water content one dew point, the rains will happen. So wherever there is a heavy rains will happen, and they are also depicted with the colors. So because the concentration of the humidity we cannot see with our eyes, but the colors we can see. And at the same time here, they have used the, let's say, microwave radar in the area. Here we can see the radar. So radar means daytime, nighttime also will get the same kind of quality of the pictures. Because optical band means it will only work on the daytime, optical satellites. But radar satellites will work day and night because it is not, we would say, sun dependent, no? The radar signals. So, and at the same time, it will get the clear atmospheric conditions also. So, which they incorporate in this analysis, climate analysis. So, these I have recorded in the morning, today morning. And this free version will only give up to 15 minutes, no, 3 days, some buffer is there, it will predict for 3 days. But Pro version will give 15 days prediction. I did not subscribe about this. So here the timeline also will show. So we can also pan, zoom, it's in interactive. With the finger, we can move this pan so that if you want to stop or start, see a particular position of the cyclone and to study further more, then this time pan will also have very, very helpful. Okay, so that is the app I just want to share with you. And so to create this kind of app, what we require? We require geospatial technology knowledge, at the same time interpretation power, and we should be able to understand the cloud technology and AI technology, machine learning and web technology. All these things we need to be familiar with technology, so that then only we can create this kind of app. And in the summary, AI and geospatial technologies are crucial for addressing climate challenges, and we need to collaborate efforts to harness these technologies for sustainable development, aid democratized via cloud-based platforms, partnership among academia, government, and the private partner, real-time data analytics for proactive measures. Okay, and in the future, what we are going to do, AI-powered digital twins for climate systems and hyper-localized weather prediction models and blockchain for transparent climate data sharing. So here in the right side, we can see Earth system data means the whole data related to Earth that is being stored, and that data can be let's say classified or segregated to specific purposes by mobile environments in model actions for initial state, physical preparation, estimation scenario. So here from the different AI techniques they have used, and their output examples. So that's all from me.
If participants have any queries, they can ask.
They
Any-
might know, they might have a lot of questions.
Sir, in the chat box, nobody has written. Participants can directly unmute and ask questions.
Yes.
Hello, sir. Seema from Greater Noida, sir. So I just wanted to know more in detail about how we can have waste management. Means GIS we can use for the waste management, sir. Because people just litter waste anywhere. If you want to detect where the landfills are there, or whether what you can say unofficial disposal of waste is going on our land. So how we can use this, sir?
No, because you asked me and not related to my area of, I would say, present topic, something else you're asking. But AI related waste management systems are already plenty. So what is waste, which we don't, yesterday that madam, IIT Hyderabad madam has explained very nicely about what is waste, what kind of waste and all. So from there, we learn what the different kind of waste, wet waste, or dry waste, or some chemical waste, industrial waste and all. So where they are, I would say, putting that waste, why they are putting that waste, because it's a social responsibility. Because if I walk on the street, at the corner, there is a plenty of waste. So how we can not, how we can not have that waste in that place. So with the common sense, everybody feel responsibility, fill the dustbins with the government provided dustbins, then it will be easy, you know. And if you want, as a geospatial technology person, if we want to do with AI, we need to have the satellite image, prior and post, and temporal change. We can identify and we can get the data. Or if it is industrial waste or construction waste, if we want to place that waste into some places, so we need to get the topological data, I mean say topographic data, and that data we have to place in such a way that it should not disturb the natural course of the streams. So when I was in UK, I was that 2012 Olympics. They have asked me to, I must say, because there is a buses, long, what are the multi-axle buses which we are having now? I have seen that area, and there is a railway track, and under the railway track there is a small on the axis 90 degrees down, where only taxis, cars can only go. But the Olympic Committee asked they want to make that route for the purpose of passing the heavy vehicles. But I was the in charge for that project. Then what I should do, because the photogrammetrist, no, I have taken the images of that area. I collect the DTM and I extracted using cut fill option how much 5.3 meters down, and I quantified the area. This much material has been excavated, but I cannot put that material wherever I want to do. But there is in Edinburgh area, coast is eroded, and at that area, if you put that area, it's a by beneficial. Removing here, the cars can go, buses can move, but putting there, the environmental friendly. Meaning, so we need to think in such a way that wherever we are putting, it should help the environment. So the like stringent rules I see in UK, but in India a bit less. Nowadays they are getting aware because of the Swachh Bharat Abhiyan, this kind of stuff. Is that answer my, I would say, satisfied answer? Seema?
Yes, sir. Yes, sir. Yes, sir. So why are you using plastic bottles, sir? Sorry to say this. You cannot
Fantastic.
fill bottle.
Fantastic. Because that's only available with me now. Now I want to
Sorry,
use.
but actually we are
No,
talking
no,
about
no, no,
environment. No, that's why. Sorry, sir. Huh?
no, but this I purchased long ago. I don't want to put into waste. I clean every day in the morning, and I use the same water for the same day.
Sir, steel
But
bottle is better because microplastic particles mix up in the water itself. No, that's why.
yes, yeah, no, recently I visited to Vexel conference in Bangalore, where that complete hotel is full of glass only. So they
Yes,
fill the
sir. Yes,
water,
sir.
refill
Yes,
the
sir.
water with glass and steel cap. So I already have two steel cap. One my wife has taken to
But I think the
bank,
still
because
bottle is
still,
more sustainable, so still can recycle infinite number of times. No?
no, glasses I will prefer better than steel. Steel also stainless steel, no? There is
Yes,
a
sir.
nickel cadmium kind of trace metals which will harm us.
Okay. Okay, sir.
Copper
Thank you,
will
sir.
help us.
Yes, sir. Thank you.
Yes, sir, I think
So,
yes, sir.
yes, go ahead, Amma.
No, sir, just one question came in chat box. Sir, what resources are there to learn more about climate analysis? In chat box, one question by Edmund Barnabas
I know. Yes. What resources are there to learn more about climate analysis? What resources are more to learn more about climate resources? So, climate is a dynamic system. We cannot predict. But with AI, we are taking some help to predict somewhat. As I said, the earlier application only 87% accuracy. And I already said that news and TV, they said tomorrow they are going to rain in some places, but it didn't rain. I know, but from the app, it is not going to happen because the temperature has gone down and the wind will be heavy. It will not allow to come that one into this one. So this kind of analysis, if you want, anybody want to do, they need to understand weather patterns and but there is a lot of resources available in NOVA website. So they have already they are mature people and they are freely they are sharing their content for the educational purposes. And if you do NOAA NOVA website and they're providing all the resources to learn more about weather prediction and application and all, what data is required.
Sir, can you hear me?
Yes.
Sir, actually, I do. What I require is like a structured material which we could learn. Okay, so that we can basically understand how climatic analysis is done in detail. So, is there any courses is there to learn more about it?
Actually, I am from Geovidya. So I have worked for the 24 years in geospatial technology. I am superstar at photogrammetry and 3D laser scanning. And whatever I learned in the past 24 years, I'm trying to create courses and I want to share those courses with a minimum expenditure, 300, 400 rupees, something like that. So I'll create courses, I'll keep my Geovidya website, and any student, researchers, or any entrepreneur, any organization, they want to upskill their resources, they can do those courses. For that, I'm looking for a researchers and enthusiastic people like you so that they can join with me and create a course and keep there. So that as and when they log in and they take the course, maybe it's a 300, 400 only, no? Some kind of maintenance share I will take and the remaining you can have it. So one course, if you keep there, if 500 people or 1000 people, any number of people, and even because life is only limited, we cannot live forever. So whatever we learn, if we store that one, this can be if eternally the people, my son, his son, their son also can be benefited. They can use these courses in the AI endeavors and everything. Like now we are getting AI methodology from the previous historical data. In the same way, education also transforming to the next level. So now I am in Hyderabad and you are in Kerala, and we are able to discuss each other because of the technology and at the same time you have intention to learn. That's the reason why you are here. I am here because Ravi has invited me here to share your views because he recognized Kasi can add something to my people, some kind of synergy. So that how it is happening. So for your question, so there is because what exactly you want, I'm not able to get it. So some resources you are telling, but what resources, for what purpose, for what you are going to do that with the resources, and what you are going to learn from it, and how we are benefit to the society. So those kind of things should be this one. Anyway, the data is available everywhere. So in NPTEL also there is plenty of courses, free courses. So we can go through those courses. But data acquisition, everything, some organization will put some kind of price on it, and some will give free. for research and education purpose. Like yesterday, my friend, my colleague, Karen said, no, so there is a nominal fee for the educational or a kind of MOU for the research organizations to this organization, so that they will give access. Some kind of arrangement they can be done. So if any of you are interested to do or create a course of your own skill, I'll help you how to create a course. I'll help you how to post that course and like a learning management system, and I can make you earn while you are studying also.
Okay, sir. Okay. Okay. So
Yes, sir,
basically,
Thank you.
yeah. Okay, sir. Thank you.
Yeah, please continue. Yeah. Okay, sir. Many questions have come in chat box. How NAVIC differs from GPS and whether it can be applicable for weather prediction application. Many questions, sir.
Okay, I use Apple iPhone, somebody use IQ, somebody use Samsung phone. All for purpose is same. So NAVIC and GPS are both same, but GPS is related to American global position system. NAVIC is a different country. At the same time, Galileo is there. All is the same because the trilateralized method means that all GPS will work on the trilateralized method because 3 satellites, minimum satellite is required. Meaning, from me, if I say some other person, you are 3 meters from me. So from me, if I make a circle around me, any part of that circle, that other person can be. The other person gives some information. You are 2 meters from me. That person will make one more circle, and some other person one more circle. Ultimately, all the 3 circles will intersect at my place. That is the principle, trilateral principle. So the same way, all the GPS systems are placed in the space so that it will position by adding 3 satellites. It will the phone will locate itself by using those 3. If it is more satellites, the position is accurate. So like that, it is all is same. All are based on the trilateralization method.
Sir, you can, Manoharan sir, Madan Gopal Manoharan sir, you can directly interact with the speaker. Sir was again asking few questions.
I know, sir. Like one small interaction, like NAVIC is from ISRO. Am I right, sir?
Yes.
Thank you, sir.
So then how to incorporate machine learning approach in landslide causative factors? Next
Fantastic question. Fantastic question. What is landslide? Can you please switch on your mic?
Yeah,
Malati.
Harida, sir. Harida.
Haritha. Okay. Haritha, please switch on your mic. How to incorporate a machine learning approach in landslide causative? Haritha.
Sir. Yes, sir.
Okay. So why landslides happens? You know the angle of
Sir,
repose.
due to the climate slope and yes, sir.
Yeah. So the angle of repose, because if in a flat area, if you put any object, it will not fall. It will be there. And if you make incline at the time of 40 degrees, it will start falling. And in the same way, if it is hilly steep area and the rocks are loosely compacted, and at the time of rain, it will work as a lubricant, landslide will fall. Or arid and winter, because of the contraction and expansion, the rocks will get loosened, landslide will happen. But your question is how to incorporate a machine learning approach in landslide causative factors. Here, as I said, in the multi-criteria decision making, meaning the type of soil means surface, whether it is a granite rock or metamorphic rock or sedimentary rock, type of soil, this one, and angle, and if there is any tree or something like that, so rainfall pattern or slope pattern, everything if you overlay one on top, and finally we will get some number, susceptibility or tendency for a landslide. So we'll get that one, and we use that model by incorporating previously incorporated AI models in the same pattern or any other pattern. We will use that one, and ultimately we'll create a model so that it will give the, result. Meaning, if you give any 3D data, not 2D data, satellite data, aerial photograph or ortho photo, we cannot get the landside this one. DTM or DEM or any slope data, if you put there and if you add rock type, ultimately it will create a red color, yellow color or green color. Those kind of patches it will give, so that the administrative body will go there. They will put some kind of mesh and all along the road to stop the this one. Is that answer is okay?
Yes, sir. Okay, sir. Fucking thank you so much, sir. I need your guidance, sir. Shall I contact you in future, sir?
Sure, no problem. You request LinkedIn, so that there is Kasi Banapalli is my LinkedIn this one handle. So I'll share. Sir, Kasi Banapalli. Just type in the
Okay.
Google, you will see me.
Okay,
KSI
sir.
and request for the connection, because I have more than close to 30,000 followers I have. So if you
Okay.
connect with me, my followers will be second followers to you. So that if you need to connect some other person, it will be, because third followers means it will ask their email address, something. So if you become my
Okay, sir.
follower, then it will be easy for you to connect the right person all over the globe. So that at the same time, I'm interested to have your time in creating a course. You try to identify one course which you are good at, so that we can create a course and we can, I would say, share with the world.
Okay, sir. Okay, sir. Thank you so much, sir.
Right, Amma?
Any more questions? If anybody has any more questions, you can directly ask.
Feedback form you did not share, Nala.
Sir, I will. It's already shared, but at the end of the talk, sir. I think he's asking about previous. Okay.
Any organization can respond. Why I almost
Okay.
attendance is not any other can respond. Why I not
Sir, I think,
getting feedback from mail.
Okay.
Right, Della, 3 minutes more. Any
Yeah,
questions
yeah.
quickly?
Anybody has any
I'm
more
feeling
questions? You can ask. Sir, I
So,
think.
sir,
Okay,
one
sir.
more thing. Yeah. So there is some confusion, like in public, like whatever the prediction that government is giving or whatever warning that is giving has like accuracy flaws. Okay. What is the reason behind this? For example,
get what
if
you
there, so for example, they give a warning that tomorrow there could be a cyclone that is be hitting. Okay, but there's a chance that sometimes the cyclone may come, in some other cases it does not come. So what is the reason behind this?
Actually, Government of India is trying a lot to share the data because geospatial data means a kind of specification they have created, share the data and all. But some of the companies are not responding. That is their fear, maybe. I cannot say that.
Okay, so that
It is beyond my answering this one.
okay.
Hello, sir.
Seema.
I don't know whether it is related to your field or not, but like mangroves are there and they are like declining day by day. So can we use this technology to find or to detect this mangrove extinction kind of thing?
I love mangroves because mangroves are the indicators of the environment. Usually at the time of intertidal zone, these mangroves will grow because because I'm a meningeology person from the MSc meningeology. So where I have studied about the mangroves and all, how they benefit the environment. Because, so that is the area where the river will come and join the sea, and there the mangroves will grow with roots and all. And it will stop the nutrients which are coming from there. It will take the nutrients and mangroves will grow. And very, very interesting thing is that mangrove fruits, like, like corn is there, no? If it is below it's very close to ground, it will be like a round thing. So once it round to fall down, the root will go to it's mud. And if it is above the more length from the ground, it will be like elongated. So that in one turn, it will go to roots. Like that, it will adjust the mango trees. And it is a typical tree. And using AI and remote sensing, it has got specific signatures, the trees and everything. Using the signatures means the band with NDVI also will classify mangroves very easily. And once the NDVI is identified, and we can get the spatial extent. And temporal data also we can extract from it, the different satellite of different times. That way we can do very easily.
So, sir, can
Yes,
we
Seema.
get data available online?
Yeah, modis.
Okay, because of mangrove are threatened actually, no, because of human
Yes,
activity.
I know. But one thing is here is that modis and all will give 10-meter spatial extent. But mangroves, for your purpose, at least you need to have half a meter. Because 10 meters means we cannot see tree and that stem count everything, no? So need to have that. That's a commercial, this one. Oof, something is not. Hello? Hello? Am I lost?
No,
Sir,
sir.
you are audible.
No, audible,
Okay.
yes.
Okay. So I think the same as got a good answer from me.
Yes, sir. Thank you so much, sir. Thank
Okay.
you.
Or in our NRSA portal is there, no? NRSA data center also providing this kind of agricultural purposes. And in NIRD is there in Hyderabad, in all over India. Those also working the same kind of work on it. But not only mangroves, there are cashews, different kind of species they are working on it. So from there you will get the data. NIRD.
Okay, sir. Thank you so much, sir. Thank you.
Right, Seema. Yes, Della, can we
I
conclude the
think,
session?
sir, questions, it was a very informative talk, sir, and interactive talk. Like since you displayed everything to us, I think all the participants enjoyed the session a lot. And still you can contact sir. Sir has left his details. Please search and contact sir.
So
Sir,
maybe
we
I can
thank
write my email address here.
sir in the chat box. Okay.
Yes.
Sir, I think one more question is, Harida is asking, is NRSC providing LULC maps? She's
Yes.
asking, that question is also there.
Yeah, it is providing.
It's giving, okay.
Sir, but I have inquired. They said they are not providing.
You have to go proper channel.
Okay, sir.
So the offline, you try to contact me so that I can give a link so that maybe some of the people will this one.
Okay, sir.
So my
Yes.
Gmail address I have typed there, and my company email address. And this is my mobile number. So you can contact me at any time. But if I don't answer, don't blame me. But I will definitely answer, because I am looking for enthusiastic people, those who can create a course for their own, so that large database will get Jayvidya. Right?
Yeah, I think sir, yes.
Very happy, Della, because this kind of participants, because all the doctors and researchers know to interact with them, and their questions are also very in-depth questions.
Sir, most of them are faculty, sir. 98% are faculty, those who have registered. Yeah.
And at the same time, the first day, your principal has invited all the people, those who are interested can come and join. I mean, say, visit the university. I'll try to make a visit once I come to Kerala, because I like Kerala. My most
Sure, sir. Please
friends are in
visit
Kerala
us.
only.
Yes. Mhm.
Right. Right. Can we log off?
Yes, sir. Thank you very much, sir. Yes.